Good day, I am Patricia Cruz,
And I am Michaela Gutierrez.
and we are to present our thesis titled Eco-Enzyme Production from Saba Banana Peel Waste, Evaluating the Effectiveness of Different Inocula in Solid-State Fermentation. The Philippines has a continuously rising amount of waste, which is expected to increase further in the succeeding years. Innovative solutions are essential to address these challenges. One such solution involves the valorization of Saba banana peels. Rich in organic acids and antimicrobial compounds, these peels are often discarded as waste. However, through solid state fermentation, Saba banana peels can yield valuable enzymes like alpha amylase, enhancing cleaning efficiency and sustainability. By leveraging Saba banana peel waste, we can develop eco-friendly solutions that address waste management challenges and contribute to environmental sustainability and resource efficiency. In the Philippines, Saba bananas constitute 29.1% of banana production, yet nearly 60% of the biomass is wasted. This not only contributes to global waste, but also exacerbates environmental challenges like greenhouse gas emissions. Enzymes like amylase, cellulase, and lipase are synthesized using banana peels as substrates. The duration of fermentation influences the end products. Short-term fermentation lasting about 24 hours is ideal for producing enzymes like alpha amylase, critical in industrial starch breakdown. On the other hand, long-term fermentation of up to 3 months enhances lactic acid content, making it perfect for eco-friendly biocleaners with antimicrobial properties.
Now, let's move on to the research gap and objectives. First is the gap. Despite extensive studies on banana waste application in bioplastics, cleaners, organic fertilizers, and biofuels, there is a lack of research on using banana peel waste for ecoenzyme production. Specifically, no studies have explored its use in solid-state fermentation to produce enzymes and organic acids for deodorizing garbage decay. Additionally, the process remains unoptimized for efficient ecoenzyme production. Addressing these gaps is critical for advancing sustainable waste management and enhancing the agricultural sector's value. The primary aim of this study is to produce an ecoenzyme solution from sabab banana peel waste using solid-state fermentation and evaluate its cleaning properties. Specifically, the study seeks to perform SSF on waste sabab banana peel at varying fermentation times, determine the effect of microbial inoculum on the produced ecoenzyme, and assess the deodorizing and cleaner performance of the resulting ecoenzyme.
The significance of this study lies in its potential to support global sustainability goals. By producing eco-enzyme solutions from Saba banana peel waste, we contribute to SDG 12, promoting sustainable consumption and production by transforming agricultural waste into eco-friendly cleaners and reducing reliance on harmful chemical alternatives. This supports resource efficiency and circular economy principles while minimizing waste and pollution. Furthermore, it contributes to SDG 11 by enhancing urban sustainability, improving waste management, and reducing environmental pollutants for healthier living conditions. Economically, this research unlocks opportunities for local industries, turning waste into value and lowering cleaning costs for communities. Overall, this study fosters environmental sustainability, supports local economies, and advances the broader objectives of sustainable development.
The scope and delimitation of this study focuses on producing ecoenzymes from sababananapil using solid-state fermentation. It investigates the effects of fermentation duration and microbial inoculum type of an ecoenzyme quality and efficacy, specifically assessing their cleaning and deodorizing properties. The study maintains constant initial substrate moisture content and sababananapil pretreatment conditions and does not explore the use of additives. Limited to laboratory scale research, it excludes broader industrial application, comprehensive assessment of disinfectant properties, and the influence of external environmental factors. Other microorganism presents during fermentation are not analyzed in detail. This study utilized the banana peels as the substrate for solid-state fermentation. The peels underwent pretreatment, including oven drying at 105 degrees Celsius and grinding to 2 to 4 millimeters, to enhance enzyme quality. SSF was carried out using Bacillus subtilis and Aspergillus niger inocula, with fermentation periods of 7 and 28 days, conducting across 6 runs. The resulting ecoenzyme solution was tested for deodorizing performance and characterized. Other evaluation included statistical analysis using standard deviation and two-tailed t-tests, which p-value is less than 0.05 for hedonic tone and odor intensity. Characterization involves titratable acidity test and assays to detect specific enzyme activity. For the sample sourcing, the Saba banana peel was sourced from a Toron vendor along Victoria Street in Intramuros, Manila, chosen for its proximity to the university where the experiments were conducted. The researchers collected approximately 2 sacks or 4 kilograms of waste banana peels readily available due to the vendor's high daily sales of banana-based snacks. The collected peels were thoroughly washed with distilled water, oven dried at 105 degrees Celsius at constant weight, and ground using a blender. The material was sieved to obtain 2 to 4 millimeters particles, ensuring consistency for solid state fermentation. This pre-treatment optimized the substrate for microbial growth and minimized factors and that could impact experimental outcomes, enhancing reliability.
Our experiment used solid-state fermentation to process Saba banana peels. The peels were adjusted to a 60% moisture content by adding 450 ml of distilled water to 300 grams of ground banana peels, and then inoculated with Bacillus subtilis, Aspergillus niger, and a combination of the two. The fermentation process took place in 1 liter polypropylene vessels covered with cloth to allow for an efficient aerobic process. The experiment was designed to examine the effects of two main factors: fermentation time and type of inoculum. We ran 6 experimental conditions varying these factors to investigate their impact on the production of eco-enzyme solutions. After the fermentation period, 900 ml of distilled water was added to each vessel, and the mixture was filtered to separate the solid residue from the liquid eco-enzyme solution. The solid residue generated from this fermentation process enriched with enzymes and organic acids exhibited characteristics similar to those of bioorganic fertilizers due to its high organic matter content, beneficial microorganisms, and ability to improve soil fertility. To maximize its potential, this residue was composted at the residence of one of the researchers, enabling its further utilization as a nutrient rich soil amendment.
This study assessed the deodorizing efficacy of ecoenzyme produced via SSF on garbage déchets. A total of 500 ml of domestic waste déchets was collected, with 10 ml allocated per experimental sample. Untreated déchets served as the baseline, while subsequent samples combined déchets with ecoenzymes at a concentration of 25%, 50%, and 75%. The testing employed manual agitation under controlled aerobic conditions and a double-blind design where randomized sample labeling minimized bias. 30 untrained respondents evaluated 6 ecoenzyme pre-treated samples and a benchmark using spent coffee grounds for odor and performance comparison. Dynamic olfactory was used for odor assessment, combining sensory evaluation by a human panel with chemical odor analysis. Participants rated odor intensity 1 is the very weak to 4 very strong, and hedonic tone 1 is the extremely unpleasant to 4 extremely pleasant.
We conducted enzyme activity assays to measure amylase, lipase, and protease activity in the ecoenzyme samples. Through our assays, we observed clear zones around the application sites, indicating starch hydrolysis, lipid degradation, and protein breakdown, demonstrating the enzymatic effectiveness of the ecoenzyme. We also evaluated the organic acid content, including acetic, lactic, and citric acids, which play a key role in deodorizing effectiveness of the ecoenzyme solutions. Throughout the experiment, we adhered to safety protocols. We wore appropriate personal protective equipment to handle materials and microorganisms. Proper waste disposal and sterilization procedures were followed to ensure a safe working environment. We performed the SSF under two distinct fermentation times: a short term fermentation of 7 days and a long term fermentation of 28 days. Both fermentation periods resulted in noticeable differences in odor and the overall composition of the ecoenzyme solutions. Before fermentation, the banana peels had a distinct banana-like odor. After 7 days of fermentation, we observed a fruity scent, which indicated that microbial activity had begun to break down complex compounds into simpler volatile compounds. After 28 days, the peels became nearly odorless, suggesting significant odor reduction and potential for deodorizing applications. These results support previous studies, which also reported odor reduction through microbial fermentation. Visually, there were minimal changes in the banana peels, as fermentation primarily altered the chemical composition rather than physical appearance. Mold growth varied based on the inoculum and fermentation time. In short-term fermentations, Bacillus subtilis led to growth like cloud-like mold growth, while Aspergillus niger formed clumpy circular molds. Interestingly, long-term fermentation showed minimal mold growth, possibly due to nutrient depletion or inhibitory byproduct accumulation.
The two tables illustrate the summarized data obtained in conducting the odor test, including both hedonic tone and odor intensity. A hedonic tone threshold of 2.5 was set, where values above this threshold represent somewhat pleasant odors and values below it correspond to unpleasant odors. The error bars represented by the standard deviation reveal the variability in participant responses. Larger error bars indicate greater disagreement among participants, while smaller bars suggest more consensus. The results clearly indicate that samples 2.1, 3.1, 5.1, and 6.1 achieved the best results, with hedonic tone scores consistently above 2.5, suggesting that these samples were perceived as more pleasant. Additionally, these samples also showed relatively stable odor intensity ratings, with 25% and 50% concentration performing better in certain samples compared to the 75% concentration. The result from the two-tailed t-tests shown in the table highlight significant differences in odor intensity and hedonic tone across various samples. Notably, samples 2.1, 3.1, 5.1, and 6.1 exhibited the most favorable outcomes, with p-values of 0.01, 0.02, and 0.00, respectively, indicating that these samples significantly differed from others in terms of odor perception. These results suggest that ecoenzyme treatments, especially at concentration of 25% and 50%, effectively improve the deodorizing performance. Samples with higher p-values, 0.49 and 0.50, indicated no significant difference, implying that certain concentration of combination of treatments did not have strong effect on odor reduction. Overall, the findings demonstrate the potential of specific ecoenzyme formulation in mitigating odors, with the optimal concentration identified for further optimization and application in waste management.
We assessed the enzymatic activity of the ecoenzyme solutions using a plate enzymatic assay. In the short-term fermentation samples, no enzymatic activity was detected. However, in the long-term samples, amylase activity was consistently observed, indicating that the microbial inoculum had adapted and produced starch-degrading enzymes. Protease activity was sporadic, but there were no lipase activity detected in any of the runs. This highlights the potential for enzyme production in long-term fermentations, though challenges remain in optimizing the process for consistent results. The treatable acidity test showed that the lactic acid was the dominant acid produced across all samples, which aligns with the known metabolic pathways of Bacillus subtilis and Aspergillus niger. Interestingly, the samples fermented for 7 days showed higher acid concentrations than those fermented for 28 days. This could be due to the rapid consumption of sugars and acid production during the early stages of fermentation, while the longer fermentation period likely resulted in nutrient depletion and accumulation of inhibitory byproducts, leading to reduced acidity. The study confirms that solid-state fermentation of Saba banana peels is an effective method for producing ecoenzyme solutions. The process not only reduces waste but also provides a sustainable alternative to chemical products. Among the different inocula tested, Aspergillus niger showed the highest enzyme activity and a significant reduction in acidity. The ecoenzyme solutions demonstrated notable deodorizing properties, meaning due to the presence of acetic, lactic, and citric acids, which are key contributors to odor-reducing effect. The findings of this study emphasize the importance of optimizing fermentation conditions to enhance enzyme activity. By utilizing Saba banana peel waste, this research highlights a sustainable alternative to chemical products and contributes to the circular economy, offering an eco-friendly solution for waste management and cleaning. This research paves the way for greener alternatives in various industrial applications.
For the recommendations, building on this study's findings, future research should focus on optimizing fermentation conditions to enhance the scalability and consistency of ecoenzyme production, optimizing fermentation variables, identifying ideal moisture levels, fermentation durations, and combination of cultures and substrates is crucial for achieving consistent and high quality ecoenzymes. Third is the examining fermentation duration, Future studies should explore the relationship between fermentation time and and acid production, identifying optimal durations for specific outputs such as lactic or citric acid, and lastly, enhancing prolonged fermentations. Strategies like pH control, tailored inoculum ratios, and nutrient supplementation could improve enzyme activity and acid production during extended fermentation periods. And that's the end of our presentation. Thank you for listening.